Today I will be discussing Saffier's Principle of Learning Strategy, Concrete, Semi-Abstract, Abstract Progression. When you're using this principle, there are three stages to it: the concrete stage, the pictorial stage, or semi-abstract stage, and the abstract stage. When teachers are using this principle, they use tangible or manipulative materials at one stage of instruction, move on to pictorial representation of the same material, and then at the later stages of instruction, they deal with the same materials in purely abstract ways. This experience anchors the learning because the students are using these hands-on activities to understand the concept before they're completing the concept. So, for an example, I have concrete, representational, abstract for a math lesson. So the students fill out or are using these little slips of paper that are black on one side and white on one side, and they represent fractions. After they figure out how to use the fractions with these manipulatives, they draw the fraction. So you give them a piece of paper and they do black on one side, white on one side. What does that represent? 1 over 2 equals 2 over 4. So 1/2 equals 2/4 for fractions, and the abstract concept is the actual math concept. So during the concrete stage, the students are using tangible materials, interacting with and manipulating these materials. It helps students see patterns, anchor images, and understand and develop concepts. It also refers to the summoned abstractions when you get to stage 3. So it's kind of, think of it as a circle where you're starting with these tangible materials to get to the abstract leads into the concrete materials. So for an example, you can hand out these tile manipulative items. So students put them together to represent a math problem, and you can have them be different shapes and sizes and colors. So they can say X is blue and Y is green if they're doing an algebra problem, and they're putting them together to represent the problem. The representation or pictorial stage, also the semi-abstract stage, uses pictorial representations of the same material. The two-dimensional object represents the problem. This is the drawing that the students are making, and it can be presented by the teacher, or students can create their own pictures. Some guided questions are great at this stage, so you can say, I see you're making that fraction of white. Why is that side white? What does that side represent? Does it represent the bottom half of the fraction? The pictorial stage might look like something like this. So they might have made this in the first stage with the pieces of paper with the model. So they already made the model, and then they're drawing the model. So the X's are in the peach, the ones in the yellow, and X squared is in the blue. And this is going to represent the abstract when they're doing the math problem in step 3. Finally, the abstract stage is where students can complete the problem without concrete or pictorial process. They don't need to look at the model anymore. They don't need to look at the drawing. They can just look at the algebra problem and solve for X. So the abstract stage helps you develop a deeper understanding because the student is actually completing the problem and figuring it out. And it does connect with the concrete materials and the pictorial materials that were used in the previous stages, but it doesn't use them anymore. So in the abstract, the student completes the problem that they visualized already with the manipulatives and the pictorial or semi-abstract. So when you're solving for X, X plus 3, X plus 1, X minus 1, they get the correct answer because they already visualized it in the first 2 steps. Some effective strategies for using concrete, semi-abstract, abstract progression are modeling the concepts at each stage, using a variety of manipulatives, like I said, different colors, different shapes, not rushing the students, so letting them figure it out on their own. Like one lesson can be just using manipulatives, the next lesson is drawing, and then the third lesson is the abstract or the actual math problems. So you're taking your time. These experiences anchor learning really powerfully because the student is learning in 3 different ways, and it also helps connect to different types of learners. I mean, this helps visual learners, it helps tactile learners, and ultimately it will help a lot of other types of learners because they're doing it themselves. They're actively participating. In summation, concrete semi-abstract abstract progression provides students the opportunity to gain a solid understanding of underlying concepts through hands-on learning, and this lays a foundation for more abstract thinking. And we've been discussing hands-on learning a lot, especially with B's presentation on active learning, and this is one way to do that. So 1, you're going to use tangible or manipulated materials at stage 1 in the concrete stage. Stage 2, you're moving on to pictorial representation of the same material, so semi-abstract or pictorial stage. And then 3, you're dealing with the same materials at the later stage in abstract ways in the abstract stage. So you're going from concrete to semi-abstract to abstract progression, kind of in order. And that helps students develop concepts later on. So using manipulatives in chemistry now may help them use those same skills in chemistry in college. So this is a great principle of learning to implement in a classroom. Thank you.